Hello, engineering aspirant. I'm excited to have an engaging and a very, very rewarding conversation with you. Are you ready? Let me ask you something. Did you know the common mistake that most of the engineering students make? They treat math as just another subject, and that is a huge misconception. If you don't have strong math skills, what is the consequence? It's very simple. Your CGPA would go down, your academic performance would be bad. The reason is simply attributed to the fact that every subject in engineering is driven by physics, and the language of that physics is mathematics. Math skills are just not limited to academics. It has several organic benefits. It improves your logical memory, it improves your critical thinking, it improves your problem-solving ability. And these are the buzzwords in every engineering product development. And therefore, math is something that is an absolute necessity if you want to make a real engineer who can deliver goods in real time. So the gist of what we have been saying thus far is very, very clear and categorical. The math requirements just do not end at academics. It continues beyond, even when you're in the pursuit of your dream jobs, be it at institutions like ISRO, DRDO, or any other leading corporate entity. The very reason we are here is to enable a transformation from being an engineering graduate to an engineer. Now let's look at one of the engineering best practices employed in engineering product development, which very, very effectively demonstrates the need for mathematics. Yes, indeed, I'm talking about 1D modeling that is used to comprehend any engineering system. So let's look at the example. If you consider parachute as a system, and then you're interested in the descent of the parachute, and you would like to ask how fast the parachute is descending, all that it takes is the solution of the basic linear differential equation that you can see, and which could be formed using +2 physics and mathematics. And this is what exactly we are talking about as 1D modeling. And this also tells you that differential equations are perhaps the most powerful tools used across engineering disciplines. Any system under the sun could be modeled using the differential equation. So therefore, math is an extremely warranted skill. So the question now arises, how do you master mathematics? What are the best practices? So let's go ahead and look at them. Would you be surprised to learn that a 3x3 matrix could be represented by 3 vectors? 3 row vectors or 3 column vectors. And if these vectors are non-coplanar, then the matrix is said to be full ranked. Welcome to graphical methods. Calculus enables you to compute a curvature of any general curve or any general surface. How does that help? In fact, you can assess the force experienced by the wheels as they negotiate a hump based on the curvature of the hump. And you can also use the idea of curvature, that is principal curvatures, to recognize an image. So therefore, engineering relevance is something that inspires you to learn mathematics. The procedure-based learning can be analogously compared with physical experiment, where you can have only one set of conditions. But automated XLS-based learning is like simulation, where you can try and experiment with a host of conditions. And that is where the learning becomes holistic. Look at this powerful pedagogical technique that helps you flawlessly register a long, intense mathematical derivation. How exactly it is achieved? The flowchart is constructed based on the strategy that we adopt to insert the derivation. It is also based on the mathematical facts that go to construct the derivation, and also the conclusion that we draw based on the final result. So this is perhaps the most sophisticated, elegant way of learning derivation than the usual way of memorizing the entire mathematical derivation. One of the unique methods of learning is concept testing, that not only helps you recollect all the critical observations, but also it helps you refine your conceptualization. Take a quick glance at the math mapping. Math is being mapped to real-world engineering applications. That was just to whet your appetite. If you want to have more exciting exploration, visit Mathinova.